Dear students, now we are going to discuss Lagrange's linear partial differential equation from mathematics, isn't it? So its general structure capital P small p plus capital Q small q equal to R. So its auxiliary equation is dx by capital P equal to dy by capital Q equal to dz by R. And then the final solution, the general solution can be written as pi. It is a function, one of the function. It may be of pi, psi, whatever may be. So let us choose here pi into constant 1 comma constant 2, c1 comma c2 equal to 0. So these are the three things very important in Lagrange's linear equation. Okay, using this idea we are going to do the following problem, isn't it? Very simple problem. So see the problem. Solve mz minus ny into p plus nx minus lz into q, and then equal to ly minus mx, isn't it? So this is a problem. So I am going to solve this problem very easiest manner. So see this video. Okay, solution. This problem is linear Lagrange's linear partial differential equation, isn't it? Since it has capital P small p plus capital Q small q equal to R. So this is the general structure of the given problem. So that I can conclude this problem Lagrange's linear partial differential equation. So I am going to choose capital P, capital Q, capital R from the given problem. So which one is along with small p, that is capital P. Which one is along with small q, that is capital Q. These two things in the left hand side of the given problem. Go to the right hand side, there is no P, there is no Q. So only we are given in the right hand side without P, without Q, isn't it? So let us consider that is R, isn't it? So now we have completed choosing P, Q, R, isn't it? Now we are going to write the auxiliary equation of the problem. So we know, already we know this, dx by capital P dz dy by capital Q equal to dz by R. So let us substitute or replace by mz minus ny, nx minus lz, ly minus mx. So pqr. Let us find first constant c1. For that we have to multiply and divide by any constant. That constant should be related to the given problem. Okay, you can choose any constant, but it should be solved or we have to find the c1, or that constant will help us to get the constant, isn't it? C1 or C2. Okay, so here most suitable constants are L, M, N. So multiply and divide by L, M, N in the respective terms, isn't it? L goes to first term, M goes to second term, N goes to third term. So that I have written here, see, L in the numerator, L in the denominator. Similarly, M in the numerator, M in the denominator, and N in the numerator and the denominator. Then we are going to apply component or divide and rule. So I'm going to add the numerator. Similarly, I'm going to add the denominator also. So L dx plus M dy plus N dz, it is in the numerator. And then unlike terms we are getting in the denominator. So that it can be cancelled. It can be cancelled. So we can get 0 in the denominator. Integrate. So integral L dx M dy integral N dx. I can take the constants from the integration integrand. So L can be taken outside, N can be taken outside, N can be taken outside. So now the solution is, after integrating this, I can get C1. The first constant C1 is equal to Lx My plus Nz, isn't it? Okay, now I'm going to find the second constant the same way. Multiply and divide by the another constants x, y, z in the respective terms. So multiply by x, divide by x in the first term, multiply and divide by y in the second term, multiply and divide by z in the third term. Apply component or divide and the rule. I'm going to add all the terms in the numerator, x dx plus y dy plus n z dz. Similarly, the like terms, unlike terms we are getting in the denominator, we can cancel. So it will become 0. Again, I'm going to integrate the terms x integral x dx plus n integral y dy plus integral z dz. So after integrating these terms, I will get x squared by 2 plus y squared by 2 plus z squared by 2. I can take 2 outside from the right hand side. So the constant will be 2c2 Even though it is 2c2, the constant can be written as c2. Okay, simply write c2. C2 equal to x squared plus y squared plus z squared. Now I can get two constants. The very first one, lx plus my plus nz. The second one, x squared plus y squared plus z squared. Now go to the last session of the problem. The general solution is pi of c1 comma c2 equal to 0. That is pi of lx plus my n plus nz comma x squared plus y squared plus z squared equal to 0. Isn't it? Very very easiest problem. Students, my dear students, if you have any doubt, put it in the chat box, or send the feedbacks in the description box, isn't it? Okay, thank you so much. So please subscribe this video and give the like button. Thank you so much, my dears.